Ooh. All right, so section 2 is introducing us to data and what it would look like, because we throw this word out all the time. And we've already seen data in both classes. We did that research question, and we broke down our data set just like we can see down here. So we had our observational units as our rows. In this case, our observational units look like they are individual students, just like they were in our research question. And then our variables, what did we ask them, right? So what did we ask? And remember, they are variables because they vary per person, if people are our observational units. And then our observationals are who or what did we ask. That doesn't, the what makes it more confusing. We'll just say who did we ask. Or who did we collect data from, or what did we collect data from. Okay, what did those variables vary per? Okay, and then the whole inside, all of that is our data. So we can see here, variables are characteristics of a person or thing that can be assigned a number or category, blah, blah, blah. And then the observational, the people or things that our data is being collected from. So this exercise is one that used to be in my homework. This is a question that tends to get a lot of students confused. So I highly recommend you pause the video. We want to determine the observational units and variables necessary to determine the average number of students per stats class in California. So think about our spreadsheet. What are we going to be collecting data from, or who, or what are we going to be collecting data from? And then what is it that we're collecting? What's the question we're asking? So pause the video, come back. So I'll tell you here the most common mistake is that students will say the observational unit here is students. So what are you asking students though? Well, the number in their stats class? How does that make sense? Because then if I talk to, say, I'm trying to think of people in my Friday classes, if I can remember, I talked to Kazra and I talked to Teo, right? They're both going to give me the same number. That's not a very useful thing to do. So we don't get our data from the students themselves. What we're getting the data from are the classes, these stats classes themselves. So in our observational units, what we'd want to have is probably the CRN, right? As if I know the CRNs for my classes. I glance around my office hoping that I can find one of my folders. So 69340 is my Friday class. And then what am I collecting on that CRN? Well, I'm collecting the number of students in that class. So 50. And then I do my next CRN, which is something else. And then I'd ask somebody else what their CRN is. So our variable is the number of students. So as I said, our observational units do not need to be people. They can also be things. But you really want to break down. Thinking of that data structure helps a lot. Now, these variables that we collect can fall into two different types of categories, and one is a categorical variable. This just puts things into categories. And a quantitative variable, which is quantities, right? They're usually numbers representing counts or measurements. So this is a test question, almost always. Fairly straightforward test question, just having you identify whether things are categorical or quantitative. So we have our first exercise. I'm having you identify the types of variables in the example data set on the previous page. Now on an exam, I don't normally give you the data set because I think that makes it a little easier. Instead, I will just say study preferences, alone, small group, or big group. And you would recognize, okay, that's categorical. They're just choosing one of these three categories to put themselves in. We know GPA is a number, and that number has some sort of meaning, so we're going to call that quantitative. The CT is just a yes-no if they've attended the CT session. That's a binary categorical variable. CT sessions attended was a number of CT sessions attended. So we got another quantitative. And then club membership was whether or not they were in a club, which is another yes-no, another category. So that's all I'd have you do on a test. So I have a couple of homework questions about that. Usually a pretty straightforward test question that everybody gets right. Now within these two categories, they do break down a bit more. Our categorical data can break down into nominal, ordinal, or binary. Nominal, and just like categorical and quantitative, these sound kind of like what they are. Nominal means there, oh goodness. Nominal means that there is no ordering scheme. Whereas ordinal, there is an ordering. So examples for that, I have here political party. Regardless of our opinions, there is no way to rank political parties. But if we talk about class level, we know that freshman, then sophomore, then junior, then senior makes the most sense, right? And we don't necessarily want to do analysis. We want our analysis to pay attention to that because we don't want it to like think the freshmen and the seniors are the most similar when it does some sort of grouping, because we know that they should be the most dissimilar based on this ordering scheme that's sort of intrinsic. Binary would be anything with two categories, like the CT and club membership ones. Even study preferences, I want you to look back at that. I would consider this ordinal. It was a lone, small group, and a large group, right? So we have an ordering scheme to that, like no one, some people, a lot of people. And then our types of quantitative data, discrete. For those of you who haven't taken a discrete math class, which I don't think many have, are whole or countable numbers. So if you think of a number line, you can only hit certain things on that number line. Like the number of CT sessions attended, this is something that's discrete because you can't attend half a CT. Well, you could, but we don't record you as having attended half a CT session. If you go and sign in with Jackie or Eli, you're getting it counted for the entire CT session. And then continuous is, well, we might have some range like 0 to 4, and everything on this range is possible. That's like our GPA. Now, as a note, there are a lot of variables that I don't want you to think too hard about. An example would be something like age. I understand that I'm not going to report out to people that I'm 34.6 years old. I'm going to tell people I'm 34 years old. So I get that that is not a thing that we normally think of as continuous. We normally think of it as discrete because that's how we report it out because we're no longer children. But at the heart of it, age is truly a continuous variable. If we really wanted to, you could take a birthday and the time of testing or whatever it might be and calculate a decimal version of that. We could be much more exact than we choose to be usually. So age is continuous, though normally it is reported and collected as discrete, but it could be continuous. All right. There are also a lot of variables that are quantitative that are collected traditionally in a categorical sense. You think about income. Most of the time when you fill out a questionnaire, they don't ask you to go pull out your W-2 or your tax stuff from last year. They just ask you which range you fall into. So be very careful. Don't make any assumptions. If we say income range, we're over here. But if we say income itself, we're in the quantitative realm. All right. And then we got one big warning here at the bottom, and that is that not all numeric data is quantitative. And then I give you the example of zip code. Right? If you look at zip code, this is the zip code I had growing up, it's all numbers, right? And this is the actual issue with using statistical software. If you throw zip code in as numbers, it's going to treat this like it's just one more than this. When really it's like a whole different neighborhood. And they may not even be next to each other sometimes based on how those zip codes break down. So you would need to tell your computer program that this was a categorical data value. All right, I still went long. I talked too much. I'm so sorry. If you made it through 9 minutes of video, power to you. I promise to be better on the next one. It's a much longer section, so I've got to be better.